Hi, everybody, and welcome back to the Astro Imaging channel. Tonight, we got a good show for you. We're going to take you out into the beautiful countryside where one of my friends has built himself an observatory, and he's gonna take us through all the joys and triumphs of building a beautiful observatory and probably some of the tribulations too. Knowing Manny, he'll tell us all about it. I know that building an observatory is for many of us a long dream, like what can we do so that we don't have to set it up every night and organize this and polar line and catch those wires and everything else. All we got to do is push the button, the roof rolls back, and boop, we're taking pictures. Well, Manny gets to do that. Almost. I don't think it's quite finished, but almost. He's getting close. I want to take you on a little tour. Let me start sharing my screen. Get my glasses back on here. Take you. Present now. Your entire screen. And we'll take you out of there. Get out of this guy. And here we are showing the YouTube screen. And if I'm not mistaken, yeah. And over here, I want you to notice that there is a great big area for everybody to put all their questions and comments and tell us how your 4th of July went if you like. But mostly, for heaven's sakes, please concentrate on, the facts of, we're on the Astro Imaging channel here. And if you want to ask Manny some questions, put them in there. You'll also see a place where you can donate if you like the shows we're doing, if you think it's worthwhile. We do need somebody to help pay for the website and all the other little dumb things we've got to do. And over here, we're up at 9.05K subscribers, which means that we're doing pretty good. We'd like to get to 10,000 and we'd like to be at 10,000 tonight. So if everybody could subscribe and put in a few likes and all that other kind of stuff, we'd appreciate it. So go ahead and do that for us if you can, but mostly join the conversation over here. Okay. And there's some other things I wanted to show you. Let me see if I can get back to this. That's Manny. And there we go. Our calendar. Manny's tonight, and then Brent's going to be here next week to show us some stuff about his ZWO or ZWO, as we've heard it called lately. The week after that, Giuseppe Donatiel is going to be here, and he's a really good astro imager, and Eric has brought him on to help to share some of his work. We're going to build another remote observatory, and the week after that, we're going to talk about transient objects with Graham Hay. And then Alex, who was just on the pre-warm-up show, is going to be telling us about time-lapsing nightscape photography. And then you can see August 16th, we have open dates. And once again, I encourage everybody to hit the contact button. And on the contact button, tell us your first name, your last name, and what your address is so we can get a hold of you. And tell us that you want to help put on part of the show. This show operates by people having good ideas and putting them on the air. If you, these guys are, these ladies, guys, everybody who works on this to do a presentation, yeah, they work at it. I mean, they do some pretty good work. It takes some effort to put together their PowerPoints or whatever they're going to do. But mostly they're just sharing information. And I think anybody who can figure out how to run PhD guiding can figure out how to do a PowerPoint enough and share some of their experiences. You don't have to be anything. You don't have to like know everything there is about something. It's okay to say on this show, I don't know, but it's crowdsourced. We get some more information from other people. At any rate, that's what I had to say, and I'm going to stop presenting, and I'm going to get off the air, and then Manny can tell us who he is, where he's coming from, and what he's got to tell us about. Manny, take it away.
Okay, thank you. Can everybody hear me out there?
Yeah, you're good. You're good.
All right, let me share my screen. And get standby here. Okay, can you folks see that?
Yeah, you're looking good.
All right. So, hello everybody. It's an honor to be presenting here at the Astro Imaging channel. I'm going to tell you a little bit about my adventures in building, outfitting, and operating a remote observatory. I guess the first thing I'd like to tell you is this is very much a work in progress. So if you're looking for the be-all, end-all solution that's turnkey, ready to go, and me telling you precisely how to do it for yourself, you might be disappointed. However, I'm going to tell you what I've done so far, and definitely have made some progress, have had some disappointments along the way, but we'll get into it, and hopefully you can take something away from this presentation. So kind of the cover slide here. This is actually a photo that I took back in, I think it was probably 2015 or 2016, from what I call Observatory Hill, and we'll get into where Observatory Hill is and why it is where it is in a moment here. So just a very quick kind of an agenda. We're going to talk about how we decided to build the observatory where we did, and then a little bit on how we outfitted it to begin with, and then really my kind of phased approach to making the observatory autonomous. It's not an all or nothing game, at least not for me. And so I'm going to talk a little bit about that. I'm going to talk about thermal. That's a big deal, and there's been a lot of discussions online about it, and I just want to kind of tell you how I'm thinking about thermal. And as Alex said, no observatory comes without its challenges, and I've certainly had mine, and we're going to talk about those. And then just recently, very recently, literally within the last month, I've put in a new scope and mount, and I just got a slide on that. And then talk to you a little bit about where I'm going in the near term in terms of upgrades, changes to the observatory. So first, a little bit about me. I'm Manny Leinz. I guess the first thing I want to tell you is that I'm a happily married husband and father. Been married for 33 plus years now. I have 3 grown sons. In my work life, I was an engineering manager for the Boeing Company, their space business in Huntington Beach, California. I retired back in 2015. The most recent thing I worked on for Boeing was what's called the Starliner, which is the Boeing spacecraft that's going to ferry astronauts to and from the International Space Station. So if you've been following SpaceX and their Crew Dragon, we're the other guys, and have had one flight. Unfortunately, that we're going to need another flight to prove out some of the capabilities for that spacecraft. I was responsible for the rendezvous and docking sensor system, and also some of the avionics, power controllers and that sort of thing on board that spacecraft. So I'm very anxious to see it successfully complete a docking, hopefully later this year. But that's neither here nor there for this group. I've been an amateur astronomer for a long time. Initially started out, with visual astronomy and a small telescope. The first one I bought was an LX6 back in the 80s. It was a used Meade LX6 10-inch Schmidt-Cass, and I did some good work with that. More recently, I've gotten a bit into astrophotography. I've been a member of the Riverside Astronomical Society now for a few years, and I always dreamed of having an observatory. A lot of it is I found that I didn't use my telescope as often, probably as I would have liked. I found that it took too long to set up and too long to tear down, and not enough time in between spent actually doing the astronomy. So for that reason, I decided that once retirement came, it was time to go and really get serious about building an observatory. And besides all that, I do like to travel and do photography other than just astrophotography. I like doing nightscapes as well. I play a little guitar, and I like researching family history as well. So the site, where did we ultimately build an observatory? So we've been thinking about a vacation home for quite some time. I like to ski. I didn't put that on the other chart, but so initially we thought maybe somewhere in the Eastern Sierra would be great, but as it turns out, the homes there are quite expensive. The lots are postage stamps, and if you're close to Mammoth Mountain, the sky's not very good. So a friend of mine suggested I try the Western Sierra. And so that's where we concentrated our search back in 2014. So we were looking for a place that had a vacation home, and then the observatory, really thinking about what do I want this observatory to do? And really, it's kind of an all the above solution. I still enjoy visual astronomy. I want to get more serious about astroimaging. And most recently, I've been involved with the club here in doing some electronically assisted astronomy, and that's been a lot of fun for outreach. And then also, I would love to get into doing some citizen science work in the future. Perhaps some of the things some of the people in the club are doing with asteroid light curves, or maybe even exoplanet follow-up imaging. Those sorts of things are interesting to me. I'm an engineer, so I love data, and I love analyzing scientific results. So ultimately, we bought a property out in near the town of Mariposa in December of 2014. It's Bortle Class 3 sky. So here's a dark sky finder image of the surrounding area. So we're in the green/blue. It's pretty dark. And of course, with a house on site, it's comfortable. You got comfortable sleeping arrangements. That eliminates the need of having a warm room in the observatory. And it's a real bonus that Yosemite National Park is within an hour's drive of us, because we love it there. You know, unfortunately, it is a long drive. I mean, it's over 5 hours from where I live in Chino Hills. We started our search actually in the local mountains here in the San Bernardino Mountains, but there's no place dark there. I mean, this right here is about as dark as it gets in the local Southern California mountains, and I determined that wasn't going to be good enough. So we decided to go up north. The other thing is, because it's so far away, if you're going to be autonomous, the systems really need to be extremely robust. If something breaks, it's 300 miles, over 300 miles to go fix it. And if that's something that breaks is your roof motor, and there's a storm coming in, your equipment is going to be soaked before you get back. So that's definitely a major consideration. And of course, it's not the cheapest to go buy a house when you want to have an observatory. So I appreciate it's maybe not for everybody. So what we decided to do ultimately is go with a roll-off roof design. So as opposed to a dome, and there are a number of reasons for that. One of the primary reasons was, so we're not there at the house all the time. And so we're looking for something that's inconspicuous. So it looks like a shed. It doesn't look like an observatory with expensive equipment inside. So I really liked the innocuous look of it. And also, it's simple. You know, you don't have to have a dome rotator like you do with a dome. You just simply need to slide the roof off. Now, our house is to the east of the observatory. And so the next question was, well, which way do we want to have the roof roll off? And typically, so the observatory is aligned north-south, the major axis. And typically, you would roll the roof off to the north. But we decided to roll it off to the east toward the house, so that we could put a little wooden deck there, maybe with a pergola, and make it aesthetically kind of a little bit more pleasing. And so that made us decide to roll off to the east. And there are some issues that resulted because of that, which I'll get into. So it's 15 by 8 feet size. So that's 120 square feet. That is not an accident. That is the largest size of building that you can get in the state of California without a permit. And so it's a shed. as far as the building department is concerned. It does not have permanent indoor power. It has plug-in power. So if you want to think about the power inside the observatory, it's on an extension cord. So think about it that way. So a lot of folks go like a 10 by 12. The reason we decided to go 15 by 8, the additional length facilitates better putting in 2 piers. And so the way it's set up is the north pier, which is currently installed, is for astroimaging, and the south pier location is currently not used, but ultimately it'll have a visual telescope attached for naked eye or through the eyepiece observing. So there's 2 ways to go. You can have this be a concrete slab, or you can go with a platform floor, kind of the two, and which basically has posts sunk in concrete. So we elected to go with the platform floor rather than the concrete. It avoids the time necessary for concrete to cure, if that's a consideration for you. The other thing is it really simplifies running cables. So if you've got a conduit that needs to go, say, from your computer desk to the piers, it's much better to have that platform floor where you can run that conduit underneath, as opposed to, oh my gosh, I didn't think of that, and so now I've got a problem because I can't get to the pier, or whatever. Maybe my cable run isn't large enough in diameter, or whatever. There's an opportunity to retrofit cable runs, which you certainly can't do with a concrete floor. So I initially thought about building the observatory myself. I'm a reasonably handy guy. I've done a fair amount of construction type jobs, type work, to the degree of custom patio covers and that. But ultimately, I decided that this is going to take too much time to do myself at a remote location that I'm maybe only going to be up at once a month or so. And so ended up contracting with an outfit called Backyard Observatories, and you see their link there. Gentleman by the name of Scott Horstman and his 2 helpers came out and built our observatory in 2017. They have a proven track record. We have our observatory is number 253, so they've built quite a few. And as I said, you've got a shortened time to first light by having somebody build it, as opposed to doing it yourself. So there's an image of the observatory, and now tempting fate, I'm going to hop out of my presentation and show you a quick 60-second video of the build, and hopefully this is gonna come through here okay.
It's going good.
Good. So 3 days altogether. So here's the guys. You can see the platform has already been started by the time I started this time lapse. And the walls went up pretty quickly on the first day. That's half-inch siding, I think, plywood siding there. Second day saw the gantry being built. And you can't really tell here, but those are, I believe, 1.5-inch angle iron tracks for the observatories. So it's quite stable. And then this is plastic siding, pre-hung door. And that's it. That's all there is to it to build an observatory. So 3 days. Day number 4, we had on day number 4 we had the pier put in. Let me go back to the presentation. So day 4 we had the pier put in, and there it is. Actually, just before it got installed. So this is the typical construction, right? These are sonotubes. And they go down, I would say there's about 500 pounds of concrete in the bottom of each one of these 2 piers. You can see the conduit coming up, which goes to the site where the desk is, and I'll show you that in a later slide. We had so the first telescope here is a Celestron 11-inch mid-cast, And so, of course, you got to put that on the top of a pier. The unfortunate thing about the CGM 1100 mount is that there's a single bolt that goes in from below. So yeah, so the way we did this is built this custom thing here. I had a friend that has a machine shop, and so put this on 3 individual bolts here that go into the adapter that came with the pier. And by the way, BYO, Backyard Observatories, supplied this pier as well, and it is quite stable. And so by 2000 and late 2017, I think January, this is January of probably January of 18, all was in place and we were ready for first light.
Could you hold
So
on for a minute, Manny? Could you
sure,
hold on for a
sure.
minute? You made a comment earlier about electricity is not plugged into it's not hardwired, I believe.
Yeah.
Are you going to speak to that later?
Probably best, I'll just talk about it now for a moment. And actually here on this slide, you can see an electrical outlet right here, and you see an electrical outlet right here. There are other electrical outlets on the other side. The roof motor is to the south, so this is looking north. The roof motor is to the south, and there's an electrical outlet there. So the roof motor is plugged into an outlet. The computer, which will be sitting on this desk, is plugged into an outlet. Everything's plugged into an outlet. That is all going together to, I think there might be a photo later, but all of these wires are plugged into a GFI outlet that's just on the other side of this wall. So as far as is it like having a hardwired system? Is exactly like having a hardwired system. The only difference is I can walk out this door around the side, and if I wanted to demonstrate to someone that this had quote unquote temporary power, I could simply unplug the cord from the on the other side of this wall, and the power to the observatory would be down. I should probably point out that the property has the service entrance is a couple hundred feet that away to the north, and actually had it trenched all the way up to here. There are 2 separate 50 amp circuits, both on GFCIs, that are just on the other side of this wall. One of the circuits does power the telescope, the mount, all the accessories, computer. The second GFCI line is intended ultimately to power something like an air conditioner, if that's required to keep the observatory cool enough during the summertime. So we'll talk a little bit more about that. But hope that answers the question.
Did you had a underground conduit running from the power supply all the way up to just the other side of that plug, and then that's basically an outlet right there, and there's a little pigtail coming in to contact it, right?
Exactly. It's like a power cord, basically plugging it in. It would have been a simple matter, right, to just hardwire it right there to a breaker, and there's a breaker panel there, by the way. It would have been simpler even to run it that way, but by code, you can't do that unless you get the observatory permitted. And I should say that I really wanted to go bigger than 8 by 15, but I did a search for basically to try and get a design for a larger observatory. And maybe somebody online knows how to do that better than I do. But I had difficulty finding someone with experience that had experience with this building department in the area. And ultimately, rather than continue to fight it, I gave up and said, it's an 8 by 15, 120 square foot shed.
Manny, I saw a comment earlier, and I was thinking you have critters that are going to reside under the observatory.
So we'll talk a lot about critters. Yeah.
Okay. We also had a question coming in about from Guillermo. Is the pier isolated from the platform? And I think you have a real good picture of that.
Yes, actually, if I go back a slide, it is definitely isolated right here. And you'll notice there's a hatch here, and the plywood basically gets reinstalled afterwards, but the pier sits on these 4 bolts, and yes, it is completely isolated from the structure. There, I can jump up and down on this floor, and you see absolutely no evidence of any jitter in the IPs.
Did BYO do all the pier pouring and everything else?
Yes, they did. Yeah,
And
BYO, yeah, and
and
the internal electrical as well.
and they did that before they built anything. So those piers were poured before you built the building over it.
That's right.
Do we have all the Eric? Do we have all the questions as for now?
Yeah, I'm looking. I think we got everything.
Okay.
Okay.
So
Okay, proceed, Mr. Manny.
all right, moving on. So kind of so we're into the initial outfitting part of the presentation here. So talking a little bit about what we've done here. So this, and I should start by saying this isn't here anymore. We'll get into that. But with the old telescope, this telescope, we had a two shelf stack here, and actually some carriage bolts hold the 2 stacks together. These little aluminum sleeves go over the bolts that go into the adapter. The adapters here, and that goes into the pier adapter plate, which is right under here. They go through this wood, so it's completely stable. Anyhow, so there's an eyepiece shelf here, the lower shelf, and then the upper one. These are just pass-throughs, and I have little plugs, cap plugs that go in here, and actually these are mostly capped off. So this gives you ways to run cables up to the mount, and then down to the lower level. And what I did here, which I like this solution, you can buy this strip lighting. I got mine on Amazon for an amazing, I don't remember what it cost, but it was like maybe $10 or something for a large spool of this stuff. These are red LEDs. I put them on little aluminum strips underneath here, and then also under the adapter. And you can see that gives us some red lighting. And right here, this is a dimmer switch. These are like $3, I think, on Amazon. And you really want to use for LED dimmers, you want to use a pulse width modulated control rather than just a potentiometer. Somebody wants to know more about that, I can talk to you about it. But yeah, you really don't want just a potentiometer here. You want something that's going to modulate the waveform of the light. Okay, so right in here, this is my computer desk. Pretty solid. I could stand on this very easily, mounted to the wall, no supports underneath. It makes a nice computer desk that gives room around this north pier. Keep going here. Okay, you're going to have power and processing. I basically have DC power bricks here for the mount, for the imaging camera, for the guide camera, for the what am I missing? Imaging guide camera, and the mount and focus motor, all that kind of stuff. There's little individual power supplies. You got to have a computer. This is nothing fancy. It's a Windows PC. I have a little red LED backlit keyboard that I really like. And the other thing I might know just very briefly is there's a guy here, if you look at this website, that has developed a red screen mode, if you will, in Microsoft Windows that is basically just a couple of clicks, and that takes you into a red screen kind of a mode. I really like this. It avoids you having to have, putting your Rubylith or whatever it is in front of your computer screen. I basically just dim the screen all the way using the monitor controls and then flip into this night mode, and it does a pretty nice job. Okay, so here's what my initial configuration was. This is not, I'll show you what it looks like today, but you can see the CPU down here, dual screen monitors. This is that same computer setup I showed you last time. Here's my dual stack. And then here's the CGEM 1100. In this case, folks will notice that I'm not using the main optical tube. I've got the camera here, ASI 294 MC Pro. This is a one-shot color camera. It's hooked up to my little stellar view scope because I was doing some wide field imaging at the time. And then here's the guide scope right here underneath. And of course, there's a whole bunch of cables here. And this is, those of you I'm sure on the line know that this can be problematic. I had certainly my share of troubles with this, and that was in no small reason why this mount is no longer being used for astrophotography. And anyway, I have a little monochrome QHY camera here, does nice as a guide camera, and a 60mm guide scope. Okay, so I'm an engineer, right? And so every engineer has to have at least one, what we used to call in the business, an eye chart. So hopefully this is like visible on the web here, and I'll try not to spend too much time on it, but I really approached this in phases, the whole autonomy situation. And so I call phase one the sneaker net approach, right? So you take your pictures locally, and then you put them on a flash drive, and you take them home or wherever to do your processing on them. And so you need power, you need the power bricks I talked about, you need a scope, you need, you've got manual focus. I used the button off mask. You've got a scope and a guide camera, as I talked about. I've got another screen coming up here. But then next you go to phase 2A, and now your control is from the house, the local house on the property, and you start up and you shut down manually, but you can teleoperate all of your imaging. And right now I'm like between here and here. So what I can do now is I can fire up I can open the roof, I can get my setup going, and then I can go into the house and do my imaging from there. So of course the main thing you're going to have, you got to have web connection for that. I'll talk about that a bit, and I'll go on a little bit. But so then the next step is that you're fully teleop, right? So from the local home, you can start, stop, open the roof, close the roof, do everything you need to do basically from the house without even having to go to the observatory. Then finally, there's teleop at home from Southern California, and then full remote autonomy. So that seems like a lot of steps. And again, I don't know that I've got time to go through this chart because there's a lot on here. But if somebody has questions, they can certainly I'd be happy to answer them. But the main thing here, as you get into these higher levels of autonomy, what needs to happen is you've got to start having obviously the roof control implemented once you get to the full teleop, and then if you're going to be remote from 300 miles away, you need a battery backup system. And then if your telescope protrudes above the roof, you've got another complication, which is making sure that you've got Ethernet, obstruction sensing built in here. And then further, you've got to have autonomous closing on the reins in the event of rain. So between these two, really it's, deciding that if you're going to really like go to bed and let the thing image on its own all night, then you really need to move into this stage. This stage here, you're watching it, you're far away, but if there's something wrong, you can hopefully take care of it remotely without relying on the autonomous system to automatically close the roof for you. In this case, you're going to close the roof knowing that there's that clouds have moved in or whatever. So yeah, so as you move into here, it's basically more of the fail-safe capabilities that need to be added in order to really make it work as a fully autonomous station. And I'm here, moving to here pretty quickly, and getting from here to here is the hard part. And I see myself running in this mode for quite a while before I go here. So we're going to work this way a while, go to here, not trying to jump all the way into this full remote autonomy, and then have have the roof stuck open with the rain. So I don't have a lot to say about these modes tonight, but maybe in a future presentation, as I move up the autonomy curve here, maybe I can come back and talk a little bit more about how that's going. So I mentioned internet. The key to phase 2A is internet. And so here you see my friend trenching for me. Boy, friends with backhoes are really indispensable. And the same friend also had a machine shop. So I bought him dinner a couple times. So that's a wonderful thing to have that kind of help. You can see there's some big rocks here that weren't fun to go through. But ultimately, very quickly, I thought about perhaps doing a wireless link between the house and the observatory initially, but ultimately I just couldn't convince myself that that was going to be reliable enough, and it's just one more thing to go wrong. And so I get a lot of peace of mind knowing that there is a hard wire, and there's a spare cable, by the way, in case something would go wrong, a spare conduit as well in there. The final link that's needed, of course, is you need an Ethernet switch. Mine has a Wi-Fi hotspot built in, so this is great. I have my phone with me. I've got a wireless hotspot here in the observatory, so I can get text messages, I can make phone calls. I'm very nicely connected here in the observatory, both wirelessly and via the hardline Ethernet. Weather. So I currently have a weather station. This may not be the be-all, end-all solution, but it does pretty well right now. I chose this station from Ambient Weather. It's a WS0900. It has quite a nice capability. It gives you indoor and outdoor temperature, so both in the observatory and outside. It gives me wind speed and direction. It has a rain gauge. It has a barometric pressure sensor. So it has pretty much everything you want here. It does not have an all-sky camera. It does not have cloud detection capability. That's coming at a later date. This hooks up to Weather Underground, if anybody is familiar, wunderground.com. And so this gives you some of these nice displays and also allows you to download the weather data from prior weeks and months if you're so inclined to do that. So it can give you a nice idea of weather trends as well. Okay, currently what we're doing remote control wise, and think about this as the phase 2A, 2B kind of solution. I've got a number of these Wi-Fi smart outlets inside the observatory. These things are controllable through a smartphone app, which works pretty well generally. And then the PC is running an app called TeamViewer, which is a free app. I really love that. And so far, this has just worked great for me. I can be inside the home there in Mariposa and log directly into the computer screen. And I can do that from right here where I'm sitting in Chino Hills. That capability is online right now. I can, from right where I'm sitting here 300 miles away today, I can turn on the computer in the observatory and I can log into the computer as well. I could probably move the mount as well today, although I'm not going to do that yet. Okay, I'm talking a little bit about thermal. This is one of those things, I've done a lot of reading on this, and perhaps somebody out there, certainly probably somebody out there knows more than I do about this problem, but I could say that the one thing I've read on cloudy nights and elsewhere is, hey, don't insulate your observatory. Just leave it bare wood because you want it to cool down as quickly as possible. Of course, when you do that, it's going to get really hot during the daytime. And yes, putting a window air conditioner in the observatory is an option. It's already framed. I'm prepared to do that if I need to. But I've been looking for something that's a little bit smarter solution. So as of right now, my thinking is to do something that looks a bit like this. So here's the framing, the observatory wall, and the roof, of course. And what I've got, and this has already been done, I've got this thermal barrier insulation called Reflectix. That's the trade name, the trademark name of this insulation. And so this is a radiative barrier. So it has low thermal mass. And the idea is here, it's going to reflect that solar radiation back out as opposed to it going through. It relies on having an air gap. So you want an air gap between your outside siding and the reflectix, and then you want another air gap inside to whatever your wall material is. Here, so the name of the game here is you want to reflect the solar radiation out, but you want to maintain a cooling system that has low thermal mass. And so that's what this does. So this is, my thinking currently is 1/8" masonite. Others have said, hey, use pegboard because it breathes and you can get some of the heat out of it. My initial thought is to use the 1/8" masonite, and we'll see how that works. This has not been built yet, but this is the plan. In the event that takes too long to cool down, my thinking is to do something like this, to basically have two different channels, one of them that cools down on the hot side of the reflectix, and then one, if necessary, that would provide some ventilation on the cool side. So this is the internal part of the observatory and obviously the external wall. So I don't think this would need to be done, this kind of an approach. If I do it at all, it would be done on the west wall and the south wall, maybe the roof, but probably not. So how are you going to know, right? How do you know if this works? So I'm an engineer, so I like data, and the way we're going to do this is with a little single board computer. This is called a Raspberry Pi. Some of you might be familiar with it. I built a little custom breakout board. I got 10 of these little digital temperature sensors which plug into these separate outlets, and there I've got it, a multiplexed 10-channel temperature sensor. So I can instrument wherever I would like, the outside wall, the inside wall, the telescope, pier, the back of the scope where the mirror is, etc. And this, to me, is all going to be about figuring out the thermal time constant. How long does it take to cool down? And so, if we can get that telescope to reach ambient temperature and the walls to reach ambient temperature within, say, an hour of sundown or so, that would be pretty good. If it takes 3 or 4 hours, that would be bad, because I'm certainly well acquainted with the thermal currents that you've got coming off of hot surfaces, spoiling your seeing, and I don't want that. So we're going to find out how this works, and maybe I'll come back and report on how well it went. So we talked about challenges. I think there was a question asked about, don't you have problems with critters? And the answer is, oh yes. So these are some photos, recent photos of the observatory. What I've done, I like to keep the dust off of my scope. And so what I did is I have a little cover that I put on here to keep the dust off. And the mice they loved that. They basically would be able to scamper right up this pier, because there's a conduit that runs up the side of the pier, which makes a dandy ladder. They would come up onto the shelves, onto the mount, on top of the mount, and you can see they built a very cozy nest under the cover and on top of the telescope. They've also started nesting on top of the roof. Here's a nice view of the roof motor here, and here's one of the little guys here. They are cute, but I would like to have them elsewhere other than in the observatory. So, and you'll notice this is some of the reflectix insulation. So this is, so here's the word to the wise. So if you're going to put this insulation up, make darn sure that there are no ways for the mice to get behind that insulation, because what they did, I had some holes, and they literally just built nests in the roof, in the rafters above the reflectix. This has now been redone. I'm not sure if I have a picture. You can see here that the reflectix was on the outside of the 2x4 studs. You don't really want that. You want a barrier, so I redid it and put it down inside. So there's that 2 air gaps that I was talking about, and the masonite will go on this surface. You'll also notice here one of my mitigation measures. This is some plastic sheeting that is hopefully going to prevent the mice from getting up this pier. And then right here, you'll notice that I have put some foam insulation because darn it, if they didn't get into the bottom of the pier and build a nest in the bottom of the pier as well. So I guess all I would say to anyone who's thinking about building a remote observatory or any kind of an observatory, especially in a rural area like this, is once the mice get into your observatory, they will not leave. I tore down all of the insulation thinking the mice would scatter to the four winds and I'd never see them again. But they just basically ran around the perimeter of the roof looking at me with great big sad eyes, wondering why I destroyed their home. So anyway, that's enough about critters. They're a big problem. Let me just say that. I've also had wasp nests and that sort of thing. They're not nearly as bad as the mice. So here, by the way, a good opportunity to show you that electrical panel. So right here, you can see the two CGI outlets here. There's a breaker box here. And then these are the conduits that run back to the service entrance. I also ran some sprinkler line while I was at it. That's up to the well house, pump house is in the same direction as the service entrance. So I just ran water lines while I was at it. There's a spot here for a sprinkler controller and also ran a water line down the hill along the same trench that the Ethernet line came at. So I now have, as a bonus, a couple of nice water taps as well. So, but this chart is all about and we talked about rolling the roof off to the east rather than the north. Obviously, if the roof rolled off this way to the north, it wouldn't be a problem as far as do is concerned. But here, you'll notice the roof remains, the edge of the roof remains to the inside of the observatory. So on a cold night, you get condensation on the roof, and it basically rains in the side the observatory. That's not good. I never thought of that little problem. And so what I did just recently is fix that. And you can see there's a rain gutter here on the outside. There's a piece of PVC that I've since put on here that basically takes the water out away from here, and this tape is gone. But now basically we have a rain gutter that takes the water away and dumps it neatly outside the observatory rather than on the telescope. Okay, this may look like a Celestron 11-inch scope, and it is, but this is a different Celestron 11-inch scope, which I'll get into in a moment. But so plan ahead. You know, this nice shelf unit that I built worked great for the C11. Once I put the new mount here, and this is a Ioptron CEM 120, what I found is, darn it, if the mount head doesn't come in contact with the top shelf. So this picture was taken just after I pulled the power plug to avoid the mount crashing into the shelf. So yeah, that didn't work. I needed to ultimately take this entire shelf assembly off here. Had I thought about this a little bit more, I would have realized before modifying the shelf to make it work with the new mount, I would have recognized that yeah, that's not gonna fly. So as I mentioned, we have accomplished an upgrade. This is the observatory looks neater now because of the mouse problem. I've taken these two big chests and put them on stands that make it impossible to build nests under them. And then this stuff is gone. This box is gone. There's no more extraneous stuff in the observatory itself. But here's this new scope. So this is a RASA, the Rowe Ackerman Schmidt astrograph 11-inch scope, and it's still got my ASI 294 MC Pro camera. You can see my little stellar view scope, which right now is just kind of operating as an overgrown finder. And then the mount here is a CEM 120 EC2. So this is a bit much for this particular scope, but it swings it very nicely. As I say, this has been here for less than a month, but so far I'm really, really happy with it. So what are we doing next? Where is
Okay,
this going?
hold off a minute, Manny. Okay, I
Sure.
think we've gotten a ways ahead on the questions. Eric, have you been analyzing the questions? Are there some that we need to?
Yeah, there's a couple. Of course, there have been many jokes about getting a cat, but I assume.
Somebody's got to feed the cat while I'm not there, though.
So I noticed that you're using TeamViewer, and I think a lot of us out here have had issues with TeamViewer in the way they don't necessarily play nice with free customers.
Okay.
Have you considered alternatives like Chrome Remote Desktop, which I use, which is I found extremely reliable?
No, I've not done that. I'm certainly open to other solutions. I know that TeamViewer, the company does not like it if you're doing anything commercial, quote unquote. So if I began, for example, maybe if I started my own astro imaging channel, I don't know, maybe I'm in trouble already by presenting here on the astro imaging channel. I don't know. But certainly if I was trying to make a profit off of anything that I was doing, that would be against the rules, and TeamViewer would require me to buy a license. So right now, I believe I'm within the personal use guidelines. I haven't had a problem with it yet from a technical standpoint, but I'm certainly, I use Chrome. I use a lot of Google products, so I'm not opposed to using remote desktop if that works well.
I mean, my personal experience is they cut me off for about 6 months.
Really?
And so I said goodbye to them. And I think their definition of what is commercial is loose enough that they can cut you off on a whim. And they probably rethought their policy because they annoyed so many people.
Okay.
But we generally have multiple solutions, like TeamViewer is back on, Chrome Remote Desktop, and there's one or two more. So if one fails for some reason, and have you solved the problems of your computer decides to reboot on its own because it thinks it's time? And what do you do next?
Yeah. So I haven't had time to get into that discussion too much, but when I get into the fail-safe capability, there's no way that Windows computer is going to be responsible for detecting a fault and closing the roof. That's going to be something like a little Raspberry Pi type computer with a probably running Linux. By the way, I should have given a shout out to my son who helped me with the software for the temperature controller that I showed on or temperature monitoring app that I showed on the prior screen. So I'm a hardware guy, not a software guy. But yeah, I would love to. It will definitely be, and I guess I've got it right here on this slide. It's going to be some solution that does not rely on that primary PC. And further, I think I might have had it on the autonomy phases chart. I'm not going to be relying on the local internet either. I mean, if power goes down, if power goes down to the house, if internet goes down to the house, if the computer goes down, all of those things, my intent would be to have like a 4G backup through the wireless network as the emergency shutdown. And then also there would be implemented some automated shutdown to where if it just loses communication with everything, it's going to close the roof.
Battery backup, Manny?
Battery backup, yes. Not today, but battery backup, it definitely is part of the equation when we get to that point.
And somebody has asked whether you'll comment on the roof control hardware.
I'm sorry, roof control, you mean in terms of being able to control it over the internet? Or just the hardware, just the motor hardware?
Yeah, probably the latter, but I'm not sure.
Yeah, so the motor was provided by BYO, and that was part of the installation. It does have limit switches built in. There's so much more that really needs to be discussed here in terms of having a backup system to detect that both that the scope is parked, and that the roof is in the closed or open position, etc. And I've got ideas for how to do that. I just didn't have time to talk about it tonight, and it's still very much a work in
Does
process.
the roof clear the scope no matter what position it's in?
Today, yes, and that was kind of a happy accident. I mean, at some point, maybe we go with a bigger scope. I mean, we go with a 16-inch long focal length scope, something like that. That I believe is probably going to interfere with the roof. But today, and it's kind of all about what kind of a shroud I put on the RASA scope. But today, it does actually, the way you saw it there, the roof does clear the scope, which is really nice. That's one less worry.
Alex?
Michael wants to know what you do about vandals or security. Or is there anybody up there?
So there are security cameras on the property. We've had no issues at all about vandalism. We've had no issues about people trespassing on the property or any of that. So yeah, today my approach has been, be innocuous. It looks like a shed. The road is to the west. The observatory is visible from the road, but it looks like a shed. And when even with the roof open, unless you really know what you're looking for, you can't even tell that the roof is open from the road. So it looks like a garden variety shed, and besides that, we've had no issues in the area. It's very safe area. We're happy with it that way.
I have one question. Do you have somebody local, you say you have no idea what's going on? Will someone just go up there and make sure the roof is closed?
Yeah, so I have a friend, my same friend with the backhoe and the machine shop, who has offered to come if that were to happen. I think I could wear out a friendship quickly if I do that too often. But yeah, there's somebody reasonably close by.
I think we're all set. Alex?
Yeah, I think there are other questions going on about suggestions for remote desktop and a few other things, and a really good idea about red screens. But take it, Manny, go back to your regular stuff that you were going to
Sure,
talk
John, and I'm almost done here. So yeah, so the next step here, which I hope to do within the next few months, is to get remote roof closure working. So that I'm either going to go with some sort of off-the-shelf commercial solution there. But what I really want to do is have a DIY solution, because I mean, the solution I was looking at that had weather monitoring and stuff built in, you're getting north of $1,000, and that's getting to be kind of a lot of money. So I'm looking at other options here that hopefully can implement maybe a near-term roof closure capability, and then perhaps we upgrade later. But that's still something that's something that's top of mind now that I'm really thinking about. And then the next thing is the smart outlets have served me well so far, but I'm really ready to go to having a power control capability that's more directly addressable over the Ethernet. And there are some switches out there that have multi outlets. So if you saw my earlier photo, I basically got a power strip that's got everything plugged into it. I really want to have individual control of the imaging camera, the mount, the focuser, that sort of thing, so that I can individually power things down if necessary. And so going with an Ethernet power control rather than smart outlets, I think is something I'm going to do in the near term. So this will probably keep me busy, along with trying out the new scope and a new mount. This will be something that keeps me busy for probably the rest of the year. So with that, it is the Astro Imaging channel, so I wanted to leave you with one Astro image at least. And this is one that I took with the new scope just a couple of weeks ago on June 24th, up from the observatory there in Mariposa. And I'm sure everybody recognizes this being the Crescent Nebula in the upper right-hand corner, NGC 6888, and some of the nebulosity here in Cygnus. And this was taken with the RASA 11 on the Ioptron mount It's 40 2-minute exposures. And, I was initially trying this out without guiding. And so these are all unguided exposures, which is not the ultimate plan. But, this field of view from corner to corner here is about 2 degrees. And I probably should have mentioned a little bit of the motivation for, why buy a RASA? Why not buy something else? I am interested very much in wide field astrophotography for a number of reasons. I really like comets. I like the idea of taking pictures of transient events that aren't things that everybody has already imaged hundreds of times over. Hopefully I can come up with some images that are a little bit more unique that way. Also, wide field is easier, right? I mean, than having a very narrow field of view and needing off-axis guiding and all that kind of stuff. So I'm not saying I won't get there, but today, being a little bit more of a novice, I like the idea of starting off a wide field. And also, this is just a super fast scope. This is f2.2, and that means you can collect a whole lot of photons in a little bit of time. So this is an 80-minute exposure altogether, and this is done pretty quickly in Deep Sky Stacker and Photoshop. And so, as a kind of an almost first light image, I was pretty happy with this. And so with that, I guess I'm ready for any more questions. But that's what I have today.
Manny, you want to comment on your software you use for capture?
So that's an interesting point. I've been trying to move on from.
Manny,
yes.
could you stop sharing your screen if you're done with your presentation?
Sure. I will do that. Stand
Great,
by
thank
here. Yeah, let me get over here now. I got my.
Is that Iguazu? What falls?
It is. Yes, it's Iguazu Falls. We were in South America last year with the for the total eclipse. It was amazing. We were in Bella Vista, Argentina. It was fantastic.
We digress, but
You
anyway,
digress.
back to work. Eric had a question. He had up, right?
Yes, capture software. So, I am still using Nebulosity 4.0. I have dabbled a little bit with Sequence Generator Pro. I'm not that good at it. I've also used Astrophotography Tool a bit, and so I'm kind of on the hunt for a new app. You might have seen on my autonomy phases chart, I've been thinking about Nina, perhaps. I really like the idea of open source software, and so maybe Nina, maybe Sequence Generator Pro. I know somebody who's written a good book on that, so I might try that. But
I'd like to meet him.
So anyway, yeah. So today it's still Nebulosity. We'll probably graduate to something else.
Somebody's asking about your tracking accuracy of your mount.
Yeah, so I have not measured it. As I say, I've just installed the mount, but it is, if I remember correctly, the sheet that came with it was about, don't quote me on this, it was well less than an arc second. And
you're shooting 2-minute subs, so
yes, yeah. And
I
could have easily shot 5-minute subs or longer, and if I get trailing with that, I can certainly plop the guide scope on there.
You got 2-minute subs in a wide field, so
right.
Yeah, that makes it a lot easier.
Yes, yeah. So So I start easy. I go, I get more complicated as I get better, hopefully.
Anak Chan had a question. He wants to know, you got a lot of communications on the networks going back and forth up there. Do you worry about somebody breaking in and you got, computer security issues?
So that's something I probably should be more concerned about. Right now it's everything's hardwired, so I don't have to, and I do have password protection on the Wi-Fi. I probably should yet go further and and make the network invisible, the Wi-Fi network invisible. So there's probably more I need to do, certainly. But as far as today, I'm kind of feel okay about it now. I tend to be too trusting sometimes, though.
Yeah. Um, what's all this cost? Linda wanted to know you got your phases here,
Yeah.
and you don't have to specifically talk to your experience because you may have done some things. But what do you think it would cost to make an observatory?
So certainly, if you are going to, if you're trying to save money, you want to have some level of DIY capability, right? If I had built it myself, uh, there certainly could have been a lot of money saved in doing it that way. There's the costs, of course, of the imaging equipment. The highest cost is the observatory itself, and I'm going to tell you that's, if you're going to have somebody build it, that's going to be north of 10 grand. It just is. You can go smaller, if you want to have just a single mount and really want to save money, you might get under that. But if you're going to have somebody build it, it's probably in that neighborhood. You can probably, I think if you do it yourself, you could probably do it for less than half of that. And then, of course, as the PC is not expensive. The DIY internet connection's not expensive. Ethernet switches, less than $100, that kind of stuff. So it's really the observatory itself, and then the mount and the scope, which is where most of the money is. Probably
Okay.
in that order.
Jeff wants to know if there's a way we can contact you. Do you have a website where you show off some of this stuff, or a way to contact you? Now,
I don't yet have a website. I want to do that, but I don't yet. I am. You can find me on Facebook, Manny R. Leinz, Leinz. You can send me a friend request.
I think backyard observatories is pretty reasonable for how much they charge.
I think so too. And by the way, I've got nothing but good things to say about them.
That's what I was going to say. I highly recommend them. And they're
they do
really
a wonderful job.
They come knock it out in a week or in a few days. I mean, you also have to figure out, like, what's your time's worth too.
Absolutely. And the thing, quite
you're going to
frankly,
take off of work for a week and build it, or a week or two, because you're not going to do it as fast as they are.
No way, right? And the other thing kind of scared me is just the whole roll-off roof mechanism, right? I mean, if that wood warps over time, out in the elements, and suddenly your roof won't close, that's not good, right? And you really don't want to have that. And so they've got a tested design. By the way, they will sell you plans if you want to do it yourself to their design. They got plans, and they will happily sell them to you, and they're quite reasonable. So that might be an option for somebody that wants to do it themselves, but wants to spend less money.
I know you're not finished with it yet, but what would you have done different?
I would have dealt with the mouse problem a whole lot earlier. I think if I were to do it again, I'm not sure I would have the roof roll off to the east. If you think about it, that roof motor is on the south end of the roof. And so you can, when the roof closes or opens, you can see a little bit of racking in the roof. In other words, it parallelograms just briefly, just momentarily. And
so is it on one of the 8-foot? It's on the 8-foot dimension.
That's
right?
correct.
Okay, so you're trying to roll something 15 feet away.
Well, no, you're rolling it 8 feet. All right, you're rolling it the wide direction. But what I'm saying is that roof, as it begins to roll, it racks a little bit, right?
Okay.
Because the motor starts to drive the south end, and then the north end follows.
And how far away is the south end from the north end?
15 feet.
That's what I was saying.
Yeah.
It's that motor's trying to push something the other end of a rectangle that's
Yes,
15 feet away.
that's right.
Yeah, that would be
Yeah,
that's a good point.
and it works. It works fine. I talked to Scott about it before we did it, and he said, it's probably better to make it roll on the short dimension, but yeah, it'll work the other way. And so, yeah, so if I had it to do again, I might have had it roll north just because it does impact your minimum altitude a little bit to the east because you're looking over that roof, and it would be definitely lower. Another thing I would say is that, and I don't know that I would do it differently, but you could see the walls on that observatory are, I don't know, they're probably 7 feet tall, right? And so when you step into the observatory, it's a little bit like stepping into a hole, right? So if you're used to taking your telescope out in the backyard, setting it up on your tripod, or even at a dark site, right? And seeing that horizon to horizon view, you're not getting that in the observatory. You're getting that patch of sky, to the zenith and down to maybe 25 degrees or so. That's good for imaging. But if you really want the enormity of the universe to hit you, you kind of don't get that. Now, so one of the things I've thought about doing is that South Pier. What I thought about doing is basically making the observatory split level. So putting like a 2-foot platform on the South Pier, and then of course there'll have to be a railing so nobody falls or anything, but then basically so that the wall, rather than being over your head, would be below eye level. And so for the optical scope, you can both get closer to the horizon and get a much better view of the dome of the sky. So my current thinking is that south imaging, or I should say visual only pier, I might end up doing a little split level kind of a thing there.
Manny, Jeff suggested putting diagonal cables and turnbuckles and just cinching that up, squaring it up.
I could certainly do that.
Interfere with your clearance height for your scope. I don't know if you.
Yeah, as long as it's no lower than the edge of the roof, it'd probably be okay. And I have thought about that. And if it becomes a problem, that will be one of the first things I do, definitely.
Have you
So
thought
there are
about?
different levels of remote observatories. I mean, if you're building this in your backyard, you might have different requirements than if it's 300-400 miles away or even 50 miles away.
Absolutely.
In a true remote observatory, the most important thing is to close the roof without parking the mount. So you're going to sacrifice some altitude,
right,
to be able to close the mount, because if it rains, you want to close the roof.
Yes.
You don't care about altitude or none of that. You just want to be able to close the roof if a weather event happens.
Right. So
these questions are a little bit, they has to be custom to your needs.
Right. And as I say, right now with the Rasa, the roof does clear it, which is nice. So that does eliminate a worry. And so now I just need a fail-safe, absolutely can't ever fail roof closing capability. And obviously I will not be moving into those higher stages of autonomy before that is rock solid.
Manny, have you thought about the heat coming off the roof? Because I'm
Yes.
thinking much of what I image starts off in the east.
Yeah.
And so if I've got my roof off on the east, I'm radiating heat up.
Yeah, that's a good point. And that's another reason why maybe if I had it to do over again, I'd have the roof roll north. That is a good point. It's a metal roof. And so part of what I want to do with this temperature monitoring is figure out just how quickly does that roof cool down. And is there something I need to do to ventilate it and improve the cool down performance of the roof? So yeah, there's some learning yet to be done there for sure.
Okay. Now you're getting your kudos over there in the comment section. People are saying you did a good job, so that's good.
Appreciate it.
let's see. And remember, Manny does have a Facebook page. What was the Facebook page again, Manny?
So just look up Manny Leinz on Facebook. I have to tell you, I don't have a lot of asteroid images posted out there. So I do want to get a website going. I've been thinking about that. I kind of want to leave Facebook behind and move on to a website. So yeah, be looking for that sometime in the future.
And you can always contact us here at the Astro Imaging Channel by going to the astroimagingchannel.org, contact, and just say, hey, where's that Manny guy?
Yeah, absolutely.
And incidentally, if you want to see pictures from Manny's observatory on July 27th at, I don't know, 7:30, 8 o'clock, whatever it is, he is going to be putting on a virtual astronomy show. Aren't you, Manny?
I'm going to do my level best.
Yes. He and I are both part of the Riverside Astronomical Society outreach team. And we used to do about 60 outreaches a year until the Kofifis came along and we had to stop doing that. So now we get together and we had a show about a week and a half ago or so. And the last time I checked, we had 3,000 hits on that on YouTube, which is pretty impressive. So people seem to like those things. So we'll be doing that together, won't we, Manny?
We will, absolutely. Yeah,
I'm actually thinking about a second show for like on maybe like a midweek. It would be like a live star party. If I'm thinking if we can get like 20, 30, 10, 15, 20 people together from different parts of the country, somebody will have clear skies and you can do some live viewing.
Ooh, pick me, pick me.
Who's we, Toga?
We and me and my mouse in my pocket.
Oh, okay. Well, yeah. Well, you know, that is the reason we had the show on last week with Isa coming in and explaining about electronic assisted astronomy so that we could get into this kind of stuff. So, okay.
Yeah, I mean, we as in whoever wants to participate.
Yeah. So anybody want to play? Actually, yeah, contact us on the Astro Imaging Channel and be part of Tolgo's outreach. That'd be cool. Anyway, we're getting ready to wind up. As you can see, we're getting a little silly here. We're down to 62 people. Quick, before they all go home. We're already home. Anyway, join us next week. We'll be back at 9:30 Eastern time, and we're going to have a good show for you then, too. Any other questions, comments? We guys were ready to call it. Thanks, everybody. Take us out, Tolga.
Good night.
Don't forget to like us and subscribe.